All right, so today we'll be talking about energy usage, or how much electricity you're using and how you would know how much you're using and how much it would cost you. All right, so we'll go through a bit of a lesson here, and then we'll look at a few other things here. So first part, we all use electrical energy. We use it at home, school, and work. Energy consumption is the amount of electrical energy that is used. So you could say that a product has a high energy consumption. So you might say, okay, this stove over here, it consumes a lot of energy. It has a high energy consumption. That just means it uses a lot of electricity. Or if you were maybe comparing different stoves, you could say, okay, this one has a lower energy consumption. Now, why is this important? Well, you have to pay for electricity, right? And the more you use, the more you have to pay for it, right? So being able to kind of predict how much you might use, or being able to compare different appliances to maybe know which one uses more or less, is valuable. That's really what we're looking at in this lesson, right? If you had to choose between two similar stoves, which one uses less energy, and how would you know? All right. Now, you might have noticed on your side of your house a box that looks like this. They're also on, schools or office buildings. Sometimes they look a little bit different now, right? We're using smart meters now instead of the old ones that they read manually. But if you look on the outside of your house, you might be able to find one of these here. What this thing is doing is it's actually measuring the amount of electricity that your house is using. So energy is measured in something called kilowatt hours. So a watt is an amount of energy. Kilowatt just means 1,000 watts. And then hours is the amount of time you're using that power for. So kilowatt hours. That's what we measure energy in. A meter on the side of your house tracks the amount of electrical energy that is used. So in this case, the main line that goes into your house, into your breaker box that splits out into everything else in your house, it goes through this box. So the main power line coming into your house goes here, and all the electrical energy that's going into your house goes through that box. So it can, or that meter, so it can just record how much is being used. And you can actually look at it and you'll see the numbers ticking upwards. If you went and you shut off everything in your house, you might be able to slow it down or even stop it. Now, not all devices use electricity efficiently, so sometimes devices kind of waste some energy, right? And the easiest example is when we talk about light bulbs. So for example, an incandescent light bulb, that's like the old kind that look like this. They have the filament inside. They produce a lot of heat along with the light, and this results in wasted energy. And light bulbs are usually around, maybe a 60-watt light bulb, right? Watt is the amount of energy it's using. So if you put your hand near one of those light bulbs, don't touch it. It's quite hot, right? So what's happening in those light bulbs is that it has to, the electrons are going through that little filament of metal, and they're heating it up, and that's what makes light. But the problem is it also creates a bunch of heat, which is wasted energy. So for light bulbs, they are often 90% of the energy you're putting into one of these light bulbs turns into heat, and only 10% of that energy actually turns into light. So they're not very efficient at all. In the last 5-10 years, we now have LED light bulbs, and those ones produce very little heat. Right? So in that case, much more of the energy is going into the light. It's producing the light. It makes a little bit of wasted heat, but it's much less. So in this case, a LED light bulb, they usually use about 9 watts of energy. So you'll notice right here, okay, I mean, incandescent light bulbs are using about 60 watts. LED light bulbs are using about 9 watts of energy. It's far less. Now, that's kind of the most extreme example, right? Most things are kind of closer. But even if you just compare different appliances or just different stoves I was using for earlier, right? If I looked at different brands of stoves, they would probably use somewhat different amounts of electricity, right? And that's just because some of them are built better, they're built more efficiently, they might use a bit of a different type of heating element. Now, how do you compare them, Right? Let's say you had to go out and buy an appliance. How would you know which one uses more or less energy? There's a lot of factors, right? I mean, you don't know how it was made. You don't know. Right? So, fortunately, there is actually a label that shows up on almost any of the appliances out there. It's required to in Canada. It's called the Energuide label. It looks something like this. You've probably seen that if you've ever walked around an appliance store. You'll probably see those labels on them. Sometimes there's yellow ones. The white ones are from Canada. There's yellow ones that are from the US. Usually they actually have both of them on it. So new appliances they must have an Energuide label on them. And what this label does is it compares the energy usage for similar products. The arrow, so this black arrow here, shows the energy consumption for this particular appliance compared to other similar ones. Okay, so for example, let's say this is a Energuide label for a freezer, let's say. So this scale here is what we're really looking at here, this kind of this patterned box that goes from white down to black. So in this case, what this is comparing is other similar freezers. So let's say it was a regular sized house freezer. In this case, what they went is they went and looked at maybe 50 different models that were very similar but from different brands. And they looked at how much power or how much electricity each one of those used. And they noticed that all of them uses, so the smallest one, or the one that used the least energy, used 481 kilowatts. And the one that used the most energy used 683 kilowatts. And this particular one that we're looking at, it used 554. So now we can kind of look along the scale and we can say, okay, the best ones are using only about 481 kilowatts, and the worst ones are using about 683. Mine is using 554. Right? I notice that right halfway mark is here. It's down here. It's actually pretty good, right? It's in the lower part, right? I'd say it's maybe in the lower 25% of freezers out there. So generally, that's probably not a bad buy, right? If I had to choose a freezer, that would be okay. It's using. It's not the best, but it's certainly not the worst, right? It's better than most of them. Right, so I'm really just looking at where that arrow is, right? The closer it is to this side, the better it is, the less power it's using. Right? If it's in the middle, it's just kind of average. And if it's at the very top, it's using the most power compared to all the other similar freezers. So they make it nice and easy to compare, right? You don't need to worry about how it's made or the type of compressor that's in this freezer or the price of electricity. You can just look at these because these are all just comparing similar freezers and assuming that you use it kind of in an average amount throughout the year. All right, so what I'll get you to do on the next page, in a minute here, you can pause the video and you're just going to look at these. I think I have 6 or 7 different Energuide labels. I want you to decide, would this be a good appliance to purchase if you were just worried about the amount of energy you're using? And then also look through and say which type of appliances use very little energy and which ones use a lot more. So at this point, I'll get you to pause the video and then look through those labels there. All right, so hopefully you had a chance to look through the labels. Let's see here. So this one is for a freezer. Once again, it's 480, the lowest one was 481, the highest one was 683. Okay, this one is right about here at 660. So in this case, the power usage for that is quite high. Right? I mean, it's higher than kind of the average, right? The middle would be around here. So it's in the top freezers in terms of the amount of energy it's using. So in this case, I might look at some other freezers. It's not the greatest one. Now, I mean, that's only one factor I'm looking at, right? If this freezer is way cheaper than the other ones, I might still end up buying it, right? I just have to be aware that this one will use more electricity. And right, I will maybe have a slightly higher electricity bill every month because of this, right? Compared to if I bought a better one. All right, refrigerator. All right, looking at this guy, okay. Very low, right? It's way on the left-hand side here. Very low energy usage. That's probably good, right? As long as everything else seems good about this refrigerator, I might go ahead and buy this one. It's certainly using some of the least energy compared to similar refrigerators. All right, washing machine here. Yeah, seems not bad, right? It's fairly average, right? The middle would be kind of your average washing machine, so it's fairly average. It's a little bit low, right? So yeah, it's probably a pretty good buy. Right, let's look at this stove here. All right, so on average, we're using about 338 kilowatt hours per year, and that is right in the middle. So it's kind of medium. It's really just your average stove. So yeah, I mean, as long as everything else seems okay, as long as the price is okay, yeah, it's not going to use a lot, but it's also not going to be much better than other ones. But if we look at the scale here, actually, the best stove used 334 kilowatts. Mine is using 338, and the worst one used 343. So you know what? That's actually not much of a difference there. So pretty much all of the stoves are very similar. You know what? I probably wouldn't even care about energy consumption if I was choosing between these stoves, because these are such small differences. 334, 338, 343. I mean, they're all pretty much using the same amount of energy. So I don't even think I would look at energy consumption to choose my stove here. All right, clothes dryer. All right, in this case, well, just looking at the arrow, it's quite high. So this one is using quite a bit of electricity. I might look around and maybe check out some other clothes dryers. And if we look at the scale here, the best ones used 400 kilowatts. Mine is using 800 kilowatts. So mine is using double the electricity. And the worst ones were using 966 kilowatt hours. So hold on here. This is a big difference. I mean, mine is not the worst clothes dryer, but even so, it's using twice as much electricity as the best one. So it is worth looking at that scale as well, right? In this case, that is a big difference in the numbers. So you know what? I would shop around for a different one. You know, if I can find a much better clothes dryer, I might end up spending half as much on electricity. So it's also important to look at that scale, right? So look at the location of the marker. That's the easiest thing. That's going to immediately tell you, is it good, medium, or high, right? Bad. But also look at the scale, right? Because in the case of the stove, there wasn't much of a difference, so I wouldn't worry about it. But in the case of the clothes dryer, that's a massive difference. So it's important to look at it there. These labels also show up on gas appliances as well. Sometimes they're not necessarily required for those. But once again, we don't really need to worry about how they're measuring the gas usage, right? Natural gas usage. But we can just use the scale again, right? So in this case, 0.53 up to 0.82. So that was kind of the lowest gas usage, the highest gas usage. And ours is, well, right around the middle. So yeah, kind of average. Yeah, it seems like there's a decent difference between them. So maybe I could find a better one. All right, last thing I want to look at before we end this lesson is just a electricity bill. So for example, here is a power bill. There's kind of different names, right? Power bill, electricity bill. Sometimes you'll even hear it referred to as a hydro bill. I mean, not all of our energy is coming from hydroelectric. I mean, most of it comes from nuclear in Ontario, but sometimes it's called a hydro bill anyways. So let's kind of pick out some of the important information here. So let's see here. This is just an example bill. So this person owes $119 or almost $120. That's for 1 month. That's when they have to pay it by. All right, so it looks like they were using about 700 kilowatt hours of electricity in this month. Okay. So kind of key information is just at the top there. All right, you can also compare it. So in this case, this month they used 700 kilowatt hours. Last month, the same amount. This month, a year ago, so in this case, I think this is for November. So last November, they used 725 kilowatts. Okay, so it looks like this year they slightly reduced their usage. So that's good. All right, if we flip onto the back, it actually gives us some more detailed info here. All right, so here it's just, how much did they owe? Where was that coming from? So in this case, about $90 for the electricity. Delivery charge, they paid about $55 for delivery. That pays for the power lines, the transformer boxes, so all of the infrastructure, right? Because they need to get that power that's generated to your house, and that's quite a difficult thing. Right? Remember, most of the power is coming from nuclear in Ontario. So most of it is coming out of the nuclear power plants in southern Ontario, and they need to get it everywhere, right? So the delivery is covering that. It's covering the power infrastructure. All right, now the main part I want to look at here is the time of use. So what you'll notice here is they actually charge different prices for electricity depending on when you use it. And the goal with that is to try and stop everybody from using power at the same time. Right? So most people, if they come home in the evening, most people are maybe, cooking their supper between 5 and 6 o'clock. And if everybody does that at the same time, they get this huge spike in the demand for power. So they have to suddenly produce way more power. And that's challenging, right? It's challenging to just suddenly start making more power. So what they do is they charge higher rates during the busy times in order to try and encourage people to spread out their power usage. So in this case, it changes in the summer and in the winter, but for this bill, it was in the winter. So the red parts here are when they charge the most. So in this case, between 7 a.m. and 11 a.m., so the morning, and then between 5 p.m. and 7 p.m., so the evening, they charge on peak. That means they charge the most. And in this case, they're charging about 21 cents per kilowatt hour. Okay, so that's the more expensive rate. In the middle of the day, from 11 a.m. to 5 p.m., they are charging about 14 cents per kilowatt hour, so a bit cheaper. And then at nighttime, so from 7 p.m. all the way through the night to 7 a.m., they're charging about 10 cents per kilowatt hour. Okay, so if we compare these amounts, it's actually a lot cheaper, right? If you look at the energy usage here. So it costs about 21 cents per kilowatt hour during the on-peak times and only 10 cents per kilowatt hour during the off-peak. So it's actually half the price. So you'll notice a lot of people, they'll try and run their high-use appliances. So things like stoves. You can't necessarily choose when you need to cook, right? But so the things they're choosing more are things like their washing machine and dryers. Those you can kind of choose when you use, right? So a lot of people will choose to use those after 7 p.m. so that they're in the cheaper usage. And that's because, if it costs you 30 cents to run your dryer for an hour, now it's going to be half as much if you did it during the off-peak time. So that's one of the key things there, is looking at that price difference, and it is significant.